Hi, this video is on solving systems of linear equations in two variables. So we're going to take a look at three different methods. We're going to start with graphing. Graphing is when you simply graph the two lines because these are linear equations, and then you are going to see where the intersections is going to be. So these two lines, we have y equals negative 1/3 x plus 2, so the y-intercept is 2, the slope is negative 1/3. Looks like this. We are going to connect our dots. You need to be very precise when you do it by graphing. Okay, the second line is y equals 2/3 minus 1, so the y-intercept is at negative 1. And the slope is 2/3, so 2, 3, 2, 3. And then we graph this line, and we can already see that these two lines intersect. The intersection point is going to be right here at point 3,1. So that is our solution. Okay. Now next line presents a slight challenge because you need to solve, if you want to graph it, you need to solve this for y to make it easier. So the first equation is going to be y equals 1/2 x minus 2. Second equation is going to be y equals negative 2/3 x plus 5. Right, so we're going to graph it. Oops, I meant to write negative 1/2. Actually rewrite them. This is going to be y equals 1/2 x minus 2, and the second equation is going to be y equals negative 2/3 x plus 5. So first line is the y-intercept at negative 2, slope is 1/2, so here, 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 here. Graph that. The second line has the y-intercept at 5. Slope is negative 2/3, negative 2, 3, negative 2, 3, negative 2, 3. You can see that intersection. And right there, we have our intersection point at 6, 1. Okay. Couple more. X equals 2 and y equals negative 2x plus 3. So we'll the first one is a vertical line passing through 2. Second line has we have a y-intercept at 3. And the slope is negative 2, so negative 2, 1, negative 2, 1, and there's that line, and we see the intersection here at 2, negative 1. This is the solution. And just like we did with one previous problem, we're going to have to rewrite these equations here for y. So the first equation is going to be y equals negative 1/2 x minus 4. Second equation, first of all, you can divide everything by 2, so it's going to be x plus 2y equals 4. So it's going to be y equals negative 1/2 x plus 4. Let's see what happens here. So the first line has the y-intercept at 4, negative 4, and the slope is negative 1/2, so it goes like this. And do that. And the second line has the y-intercept at positive 4 and the slope is negative 1/2. Now, of course, we're assuming here that you know how to graph lines for that method to be used effectively. And what we have here is two lines that are parallel. And if they're parallel, that means they will never intersect. And if they will never intersect, you have no solution here. This is our answer. Alright, so of course this method has one disadvantage, well, a couple disadvantages. First of all, you need to be able to graph it, and the graph needs to be such that it fits in a relatively small grid, because if you're going to get an intersection somewhere at like 20, 30, you're going to need to have a pretty big grid. The second problem here is, which is even a bigger problem, is if you get a solution which is a set of integer values for your coordinates, then you are going to be okay. But if it's not an integer value, it's not always going to be easy to determine what the actual value is. Let's take a look about algebraic methods. So there are two algebraic methods we recognize. One of them is substitution. Let's talk about this. So the substitution is when you substitute one variable with an expression. So in this example, y equals x plus 6 and y equals negative 2x minus 3. So that means y and y, these two things are going to be equal to each other. So from there we can say that x plus 6 equals negative 2x minus 3. So we're going to get 3x equals negative 9. And that means x equals negative 3. So we got the value of x. How do we find the value of y? Pick one of the two equations and substitute that value into it. So if I use this equation and I substitute my x value in there, I'm going to get that y equals 3. And my solution here is going to be negative 3, 3. Okay? This equation, so we have this first equation where we know that y equals 3x minus 2. And what we are going to do in this problem, we are going to substitute that in here, where it says y in the second equation. So then the second equation is going to be x minus, we're going to replace y with 3x minus 2. So 3x minus 2 equals 4. Please be careful, please remember to put parentheses here because you're subtracting and it's very important that you handle it properly. So we get x minus 3x plus 2 equals 4, means negative 2x equals 2, and x equals negative 1. And then we take this value, substitute it into the first equation. This one is going to be easier. So y equals 3 times negative 1 minus 2, and y is negative 5. And the solution here is negative 1, negative 5. Please remember, often we write these the solutions for these problems as an ordered pair. So x first, y second. Example 7, we already have the value of y. You don't need to find that, so we just need to find the value of x. And for that we substitute that value into our equation. So 4 equals 3x minus 2, so 3x equals 6 and x equals 2, right? And then we have our solution. Remember, x first, y second. Okay, moving on. A few more problems. So sometimes it's not going to be as simple as the previous problems where you have at least one of the equations solved for one of the variables, and then you're going to have to solve it for one of the variables. So what I can do, for example, I can take the first equation, solve it for y. So it's going to be y equals 1 minus 2x, and then I can make substitution into the second equation to solve it. So I'm going to get negative x minus 2 times y here is replaced with that quantity, so y minus 2x equals negative 5. distribute, so we get negative x minus 2 plus 4x equals negative 5. So we have, what do we have here? We have 3x equals negative 3, and that means x equals negative 1. Alright, and we already have this equation here. We can take this value of negative 1, substitute it here. So y equals 1 minus 2x, y equals 1 minus 2 times negative 1, and it's going to be y equals 3. And the solution here is negative 1, 3. Right, moving on. So we're going to take our first equation here, easier to solve that one for x. So x equals 4y minus 1. Now we're going to substitute that into x here. Right, so we're going to get 3 times 4y minus 1 plus 5y equals 31. So it is 12y minus 3 plus 5y equals 31. We have 17y equals 34, and that means that y is 2. Now we take this value, x equals 4 times 2 minus 1, x equals 8 minus 1, which will give us a value of 7, right? So remember, we found y first, x second, we're still putting x first, so it's 7, 2. Alright, let's take a look at these next problems. So we can solve the first equation for x pretty easily. It's going to be 8 minus 2y, right? Substitute that into the second equation. So in the second equation we are going to get 4y, I'm sorry, that's supposed to be 4x. It's supposed to be x. So 4y plus 2 times 8 minus 2y equals 12. So we get 4y plus 16 minus 4y equals 12. And we're going to end up with 16 equals 12. This is a false statement. So what that tells us often with the equations is that this equation does not have a solution. And what happens here, this is a situation when you're going to have two parallel lines. And there's no solution here. Okay. Alright, now we're going to talk about another method called elimination. There is sometimes when they call it an addition method in some textbooks. I prefer to just refer to that as elimination because the whole idea is to eliminate one of the variables. For that we need to have equations in the same exact form. Sometimes you can get around that, but it is not always a good idea. So we will go ahead and use elimination for problems when the equations are in the same form. So if you look at these two equations, 4x plus 3y equals 0 and 5x minus 3y equals 27. What you see here is that you get 3y and negative 3y. And what I can do is I can add these two equations together. And because when I add it together, 3y plus negative 3y is going to cancel. That's going to leave me with 9x, so I'm adding 4x plus 5x is 9x, 3y plus negative 3y is 0, and 0 plus 27 is 27. And I eliminated one of the variables, so I'm only left with x. And then from here I can see that x is going to equal 3, right? And now I pick one equation where I can plug in that value. So let's say I use the first one, 4x plus 3y equals 0, 4 times 3 plus 3y equals 0, 3y equals negative 12, and y equals negative 4. And my solution here is going to be 3, negative 4. Alright. So now to take a look at example 12. So we have 5x plus 4y equals 7, and 5x plus 2y equals negative 1. So adding them together here is not going to help me, because then I will get 10x. But if I subtract these two equations, then I will be able to eliminate x. Right? And that's precisely what we're going to do. So this cancels. 4y minus 2y is 2y. Negative 7 minus 1 is going to give us negative 6. So 2y equals negative 6. That means y equals negative 3. Okay. So take this value, substitute that into one of the equations that we have. Which one you substitute it into does not make any difference. So we have this, we have 5x minus 12 equals negative 7, 5x equals 5, that means x equals 1, and then use that value and that value, and we have our solution. It's going to be 1, negative 3. Remember, x is always first. One more problem. So the challenge we have in number 13 is that none of the coefficients match. So what we often do with problems like this, we're going to have to see, well, if I want to eliminate one of the variables, can I multiply one of the equations possibly by some number and make the coefficients equal? So for example, if I take the first equation and multiply this by 2, what is it going to give me? I'm going to get here is going to be 6x plus 2y equals 10. I multiply every term by 2. And the second equation I simply copy 6x minus 2y equals 4. 2y minus 2y, my y's have opposite coefficients. I can add these two equations together. And what it's going to leave me with is going to be 12x equals 14, which means x equals 12 divided by 14, I'm sorry, 14 divided by 12, which is going to simplify to 7 over 6. Now we take this value and substitute it into one of the equations. I'm going to use the second equation. So 6x minus 2y equals 4. Substitute x with 7/6, so 6 times 7/6 minus 2y equals 4. That means 7 minus 2y equals 4. That means negative 2y equals 3, right? Negative 3. And that means that y is going to equal 3/2. And my solution here is going to be 7/6. 3/2. This is what I was talking about earlier when I said if you try to use a graphing method for this problem, you're going to end up getting an intersection. You won't be able to see what the precise value is. That is where you definitely see why algebraic methods might be more powerful. Okay. Now a few more examples. Elimination. And let's see, so what we have here, alright, this is a situation when you cannot multiply one equation by something to make them equal. So in this case you're going to have to multiply both equations by some number to be able to eliminate something. Okay. So if I look at the first coefficient, this was 4, this has 3. So if I multiply the first equation by 3 and I multiply the second equation by 4, what I'm going to get is 12x minus 21y equals negative 15. And the second equation is going to be 12x minus 8y equals negative 28. And now I can subtract them. And when I subtract them, 12x is going to cancel in both of them, and I will only get y remaining in my equation. So negative 21y minus negative 8y will give me negative 13y. Negative 15 minus negative 28 will give me 13. That means y equals negative 1. And I'm going to go back to one of the equations I had originally. Let's say the first one. 4x minus 7y equals negative 5. Take negative 1. For y, substitute that. 4x minus 7 times negative 1 equals negative 5. 4x plus 8 equals negative 5. Right? Just double check. Oh, I'm sorry, this is 7. This number is 7. 7 times 1 is 7, of course. So we have 4x equals negative 12 and x equals negative 3. And our solution here is going to be negative 3 for x, negative 1 for y, right? Okay. So this equation here, we want to make the coefficients equal. Doesn't matter which ones. For example, if I multiply the first equation by 3, I will get 3x, which will be able to cancel with the other ones. So multiply here by 3. So what we're getting from this is going to be 6x minus 9y equals 3, and the second equation is going to be negative 6x plus 9y equals negative 3. And if I subtract these two equations together, you're going to see something very interesting. It's going to give you 0 equals 0. And when you have something like that, that means that your equation is going to have infinitely many solutions. But when we say infinitely many solutions, that does not mean it's just a random x and a random y. X and y are going to be related to each other by some formula. So what that means is that I can write my solution here, so it's going to be infinitely many solutions. But what you can write your solution often as is going to be a pair of x and y, such that the relationship here is going to be 2x minus 3y equals 1, because what that tells you that there's a certain relationship between x and y that you have to adhere. So if I pick a value of x, plug it in here, I can find the corresponding value of y, and I can also do it vice versa. So this will tell us that it can be any pair of x and y that satisfies this equation. Alright, our last problem. So what we're going to do, we're going to multiply, we're looking at this and this. We do not have same coefficients or anything that I can multiply one equation by. So for what I can do is I can multiply the first equation, for example, by 3. And I can multiply the second equation by 5. What that accomplishes here is going to give me 15x for both of them. And this way I will be able to eliminate that. There we have 15x plus 6y equals negative 18 from the first equation. Second equation is going to be 15x plus 35y equals 40. And I have 15x and 15x, so I will subtract them from each other. And this way I will be able to cancel x. So when I subtract that, 15x minus 15x gives me 0. 6x minus 35x will give me negative 29x. And negative 18x minus 40 will give me minus 58. So I divide both sides by negative 29, and that gives me x equal, y. I apologize, this was y. So y, and rewrite that y equals 2, right? And then substituting that into one of the earlier equations, you will get x equals -2. I'm sure you can finish this on your own, and our solution here is going to be -2, and that's all there is to it.